Welcome everyone. Our today's topic is potential difference of a cell, and this is from lesson current electricity part 2 video of this lesson and for class 9. So let's continue. Okay, so student, potential difference of a cell. So what is it? So the difference in potential between the positive and negative terminal of a cell is the potential difference of a cell. Okay, so what is the potential difference? It is a difference, potential difference between, that means difference of a charges, that is how many charges are carried from positive to negative terminal of a cell, is the potential difference of the cell. As alongside you can observe the a type of a cell, okay, in which the metal cap, this acts as a positive terminal and the metal bottom, this act as a negative terminal. So potential difference is a difference of between potential between a positive and negative terminal of a cell. This is a potential difference. And student, this potential difference is caused by the chemical reactions occurring inside the cell. Okay, so as we know that inside the cell, that carbon rod is there, zinc is and chemicals like magnesium oxide, manganese oxide and paste of ammonium is there. Okay, so different chemical reaction takes place between all these, and due to this the charges or potential is produced between positive and negative terminal of a cell. And the potential difference sets the electron, the potential difference sets the electrons in motion. Now moving of a charges, moving of a charges means what? Moving of a electron. Okay, so the potential difference sets the electrons in motion and results in the flow of electricity. So due to the motion of electrons, what happened, the electricity flows through the conducting wire connected to the two ends of the cell. And the amount of work done to carry a unit positive charge from point A to point B is called the electric potential difference between the 2 points. So what is electric potential difference? The amount of work done to carry a unit positive charges, okay, positive charge from point A to point B, that means between two different point A to B, it is called as the electric potential difference between that 2 points. Now here we have formula for the potential difference between 2 points. It is from point A to B. It is equal to, that is potential difference is equal to work done or work divided by total charges transferred. That means work done divided by total charges transferred from point A to B. And symbolically it is represented as potential difference symbol as V, and work done times work done for W for work done, and Q times for total charges transferred from point A to B. So the formula for potential difference is V is equals to W upon Q. And in terms of unit, the unit of V or potential difference taken as 1 unit, then it is equals to 1 joule upon 1 coulomb. Okay, so the charges are used in unit coulomb, and for work done unit is joule. So 1 volt is equals to 1 V is equals to 1 joule upon 1 coulomb, and the unit of potential difference in SI unit is volt. Okay, so potential difference unit is volt, and for the work done it is joule, and for charges it is coulomb. Okay, now student, let's understand what are the free electrons. Okay, so in previous slide we have seen in potential difference that moving of a charges or flowing of a electron through a circuit, okay, or between 2 points. So what are these free electrons? What are the electrons? Now let us understand about this. Okay, so student, here you all can observe a single atom, okay, and in a single atom, between the atom nucleus is there, which is positively charged nucleus, and around the nucleus the electrons, smaller dots, you can observe the small dots are revolving around the nucleus. So these are the negatively charged electrons are revolving around the nucleus. Okay, and this is electron, and the electrons which are present in the last orbit. Okay, I have shown with the arrow electrons which are present in the last orbit, the outermost orbit. These are weakly attached outermost electrons. Okay, and the attraction between nucleus and the electrons which are present in the last orbit or outermost orbit are the less attraction will be there, okay, or weak attraction. And atoms in a conducting solid, free electrons move freely from atom to atom. Free electrons means electron present in the last shell, they are loosely held by the nucleus, okay, or weakly held by the nucleus. Now student, every atom of a metallic conductor has, metallic conductor means any metal which can conduct the electricity. So every atom of a metallic conductor has one or more outermost electrons which are very weakly bound to the nucleus. That means attraction between the nucleus and electrons which are present in outermost shell is weak, and these are called as a free electrons. What are the free electrons? The electrons where every atom of metallic conductor has one or more electrons, outermost electron, which are weakly bound to the nucleus. These are the free electrons, and these free electrons can easily move from one part of a conductor to its another parts, because they are loosely held, loosely attached to the nucleus, loosely held by, bound by the nucleus. So they easily can move from one one part of a conductor to the another part. Sorry. And the negative charge of the electron also gets transferred as a result of this motion. So as the electrons are negatively charged, so the negative charge of the electron also get transferred as a result of their motion. And the free electrons in a conductors are the carriers of a negative charge. Okay, now student, current flowing through a wire or current flowing through a metallic conductor. Wire is a metallic conductor, okay. So student, this is the diagram showing a random motion. So these are the metal wire. Inside the metal wire, free electrons are moving, and the moving motion of electrons is randomly, okay. This is random motion of electrons in the metallic wire. So student, if a conducting wire is not connected to a cell, okay, it is only metallic wire is there and it is not connected to a cell, then what happen? Its free electrons will move randomly in all the direction in the spaces between the atoms. That means they will move here, they don't follow any direction, just they will move randomly in the spaces between the between the metallic wire, okay. And when we connect the ends, when we connect the end of the wire to the two terminal of a cell, what happen? Electric force acts on the electrons, and being negatively charged, they start moving from the negative to the positive terminal of the cell. Now that means they start moving from the negative terminal, that is a lower potential, to the higher potential, which is positive terminal of the cell. You all can see in diagram also, they start moving from negative to positive. Why positive? Because positive terminal is a higher potential where the electron deficiency is there, or where there is a less electrons are there, okay. And student, due to the flow of these electrons, current starts to flow through the wire. So when the electrons will flowing through the from negative terminal to positive terminal, or lower potential to higher potential, what happened? The current will flow, the current start flowing through the wire or through the conductor. And this motion of electron is irregular, but there is a definite non-zero value to their average velocity. Okay, now electric current. What is electric current? So student, this is a circuit diagram. Here I have shown a battery and negative terminal, positive terminal, okay. So what happened? The direction of a current is from positive to negative, but the flow of an electron will negative to positive. Alright, and when the electricity will produce within the conductor, a bulb will start glowing. And electric current is the flow of electrons through the conductor, okay. So that means when we connect a wire, metallic wire, through a cell, or we will connect a proper circuit, then what happen? An electric current will produce. How? By the flowing of an electron through a conductor or through a metallic wire. Now student, quantitatively, current, which is denoted by I, is defined as a charge passing through a conductor in unit time. So what is a current? It is current is defined as the charge which passing through a conductor or a wire in unit time. And if charge is taken as Q is flowing through the cross section of a conductor, that means cross section means within a conductor in time t, then the current is denoted by, symbolically it is represented by I is equals to Q upon T. That means the charges passing through a conductor in unit time. Q stands for charges, T for time or unit time. Okay, and student, the unit of a charge in SI unit is the coulomb and current is expressed in terms of ampere. And the charge of one electron is 1.6 into 10 raised to minus 19 coulomb. That is so small. Okay, now ampere. Definition of ampere is 1 ampere current is said to flow in a conductor if 1 coulomb charge flows through it every second. And formula is 1 ampere is equals to 1 coulomb divided by 1 second, that is unit time. And student, remember this one, that even though the electrons will move from negative to positive terminal, that is from lower potential to higher potential, but conventionally the direction of current flow is taken to the opposite of the direction of flow of electron. That means from the positive end to the negative of a cell. In our previous slide also I have explained you that the direction of flowing of electron is from negative to positive, but the direction of flow of electricity, flow of a current is taken as from positive to negative. So these are opposite to each other, electrons flow and flow of a current. Okay, so as I have shown you with the black arrow, flow of electron from negative to positive, but the direction of a current is from positive to negative. Alright, now introduction to scientists. So student, a unit volt. Okay, so the Italian scientist Alessandro Volta constructed the first electric cell, and the unit of potential difference is named volt after in his honor. And volt, the cell I have shown with a blue circle, this is an electric cell constructed by the scientist Alessandro Volta. Okay, student, here one question. Let's solve one question. A current of 0.4 ampere flows through a conductor for 5 minutes, and how much charge would have passed through the conductor? So first of all, what is given here? Current is given, that is I is given 0.4 ampere. It is flowing through a conductor of 5 minutes. 5 minutes this time is given, and we have to find out the charge, that is Q. So given is I, current 0.4 ampere, T, time, which is 5 minutes. Now here we will convert time into seconds, that is multiplying 5 with 60, we will get 300 seconds. Okay, and formula is Q is equals to current into time. Okay, now here Q is equals to 0.4 ampere into 300 seconds, which is 120 coulomb. Charge is 120 coulomb. So charge passing through the conductor is equals to 120 coulomb. So student, that's it for today's video. I hope you all have understood. Next part we shall do in next video. Thank you.